Hi, you are welcome to this video. In this video, we are going to be discussing surds. We're going to be looking at an rule of surds. We're going to be looking at basic forms and similar surds, conjugate surds, and rationalizing the denominator. So this is going to be very exciting. I'd like you to sit tight and enjoy. So to start with, let's look at what surd means. What is surd? When you hear surd, what comes to your mind? Right. We when we are solving mathematical questions or mathematical problems, we come across those terms is when you are told sometimes to leave your answer in surd form, and especially in the area of trigonometry, we also hear of some special angles which are represented in surd forms, right? And stuffs like that. So, but then there's nothing special about that. When we hear surd, what we are trying to say is some numbers that can be represented like this. Let's say a, right? 2, you know, 2 root 2, or let's say a root b, something like this, right? So this is what we talk when we this is what we mean when we talk about surds. So there are some basic rules as relating to surds, and as we solve further you are going to be seeing much of those. But then we have two basic fundamental rules here, which is multiplication and division of surds. For instance, if you have root square root of a times b, right, this is equal to square root of a times square root of b. You can split it instead of having it and the same way like this. So this implies that if you have let's say square root of 2 times 6, right? So this can be written as square root of 2 times square root of 6. So that is what the multiplication rule is saying. So similar to the division rule, similar to the multiplication rule, the division rule states that if you have the division, right, two numbers dividing themselves, and then you take their square root, this is the same thing as taking the square root of the numerator and dividing it by the square root of the denominator. Where if you have the square root of 2 divided by 3, this is the same thing as square root of 2 divided by square root of 3. So that is what that division rule is talking about. So we have some examples here which is similar to what I've done here, right? So but then it is quite different for addition, right? It is quite different for addition. It is not the same for addition. For addition, square root of a plus b is not equal to square root of a plus square root of b. This is a different ball game altogether. So you can see that from here it is not the same thing as addition, right? So let's look at, we have a assessment here where we are told to solve. We have the numerator to be 4 times 25 times 3. 4 times 25 times 3 is dividing square root of 9 times 4, right? So let's solve that. So from applying this law, that with these rules, you discover that we can split this to square root of 4, right, times square root of 25 times square root of 3. This is 3, all divided by square root of 9 times square root of 4. Alright, so you see that square root of 4 is what? Is 2. right? Plus square root of 25 is what? Is 5. I mean times rather, sorry, this is multiplication times, and then this is times square root of 3 dividing by 3. Square root of 9 is 3 times square root of 4, which is 2, right? So from here we have 2 here, we have 2 here, right? So we have this to be 5 square root of 3 divided by 3. So that is our answer there. So this is equal to 5 square root of 3 divided by 3. So that is our answer for the self-assessment exercise. So we look at basic forms and similar sorts. Basic forms and similar sorts. So now if the rational number under the square root sign contains a factor which is a square of a number, the sort can be reduced to a simpler form. Such a simpler form is called its basic form, right? What we've just like what we've done here, for instance, we have 25, right? So this can be reduced to 5, which is the basic form. Or say you have square root of 8, right? Square root of 8 is equal to what? We can split this to say 4 times 2, which is equal to what? Square root of 4 times square root of 2, which is equal to 2 root 2, because square root of 4 is 2. So this is what this statement is saying. The basic form, and basic form here, this is a basic form of this sort. So square root of 8 is equal to this. So this is the basic form. So let's say if the rational number under the surd root sign contains a factor which is a square of a number, the surd can be reduced to a simpler form. So in most cases in the exam, if you solve, you may not see an answer in root 8. What you see is 2 root 2, which is the simplest and the basic form of the surd. So this, let's go further. These are surd which are multiples of the same roots, right? Similar surd because each of the surd is multiple of root 5. Yeah, we have 3 root 5, we have 2 root 5, we have 6 root 5, we have 7 root 5. So these are similar, these are called similar surd. Two similar sorts can be added together or subtracted together. So what this statement is saying is you cannot add and subtract sorts except they are similar sorts. You cannot add and subtract sorts except they are similar sorts. So for example, now we have this root 20 plus root 45, right? Plus root 125 minus 2 root 18. So let's simplify this. If you simplify this, what we are going to have here is going to be a square root of 5 times 4 plus square root of 5 times 9 plus square root of 5 times 25 minus 2 into square root of 16 times 5. So let's split this up. This will be square root of 5 times square root of 4 plus square root of 5 times square root of 9 plus square root of 5 times square root of 25 minus 2 into square root of 16 times square root of 5. So you discover that if you simplify this further, this is 2 root 5 because square root of 4 is 2. Then this is plus 3 root 5 because square root of 9 is 3, then plus this is 5 root 5 because of square root of 25, then this is minus 2 multiplying 4 root 5 because root of 16 is 4. So this will be 2. Okay, now let's just try to wrap it from here. So this is 2 3 5, right? So you are going to add this. This is what the statement is saying, right? Two similar sorts can be added together or subtracted from each other. So I was trying to point out that these are similar sorts, right? They are multiples of of the of 5, right, of root 5. So that is what is going to make it a similar sort. So you can add these ones and subtract them. So two sorts can be added and subtracted if and only if they are similar sorts. If they are only if and only if they are similar sorts. So in this case, these are similar sorts because all of them have root 5. So you can add and subtract them. So here we are going to add 2 plus 3 plus 5, that is 10. 10 root 5. Then this is minus 8 root 5. So it's called that this will give what? 2 root 5. 2 root 5. So that is our answer for that. So let's look at another example, another interesting one. So let's maintain this. So you discover that from what we have here, we are going to be reducing all these other sorts to so that at the end of the day there will be similar sorts, which will make it the multiples of root 2, right? So here what we have here is 32. So if we are to reduce this, we are going to have what? We are going to have 16 times 2. 16 times 2 is 32. Then plus root 25 times 2, which is going to give us root 50, plus root what? 49 times 2 is going to give us a 98. Right? So you discover that all of these are perfect squares. That is one other thing you need to watch out. So you discover that you have to have to be perfect square, so that it can be reduced, so that you can get the square root of it. I hope you get this. It's very, very important. One of these have to be perfect squares. One of these have to be perfect squares. So we're here now. All you need to do now is just to reduce it. This is 3 root 2, and this is minus root 16, right, times root 2 plus root 25 times root 2 plus root 49 times root 2. So this is root 3 root 2, then this will be minus 4 root 2, right, because it's a perfect square, then plus 5 root 2, right, then plus 7 root 2. That's what we have there. So you discover that these are similar sorts now. They are like sorts. So, remember, sort cannot be added or subtracted except they are like sorts. So you discover that we can actually add and subtract these sorts, right? So let's do the addition. 3 plus 7 is what? 3 plus 7 is 10, plus 5 is 15, minus 4 is 11. So what we have here is 11 root 2. So that is our answer. So it says self-assessment here. You are told to look for factors of 45, one of which is a perfect square. So just look at check the factors of 45. I will allow you to do that on your own. It's very easy. Look for the factors of 45, right? And you are told that one of those factors is a perfect square. So just check it out. And that factor could be what? Is 9, right? But when you look at factors of 45, you'll be dealing with 5, dealing with 9, and all of those. So, and then that 9 is a perfect square because 9 times 5 will give you 45, right? So let's look at the next, which is a conjugate surds. We are going to be looking at conjugate surd next in our next video, and I hope you like this video. If you like this video, please just like it, and you could also share it with friends, and also subscribe to the YouTube channel. Don't forget to hit the notification bell so that you get updated each time we upload a video. Thank you.